Hi, hello, welcome to Digital Electronics. I'm going to talk more in detail about hexadecimal numbering system in this chapter. So let's go to the outline. So outline of the chapter 2 under 2.3 will be hexadecimal numbering system. So in previous class, we have covered decimal to binary and binary to decimal uh, convention. So this is under subchapter 2.1. We have covered this, and now we are going forward to go for the hexadecimal. Hexadecimal, in this chapter, we're going to do the convention on how to change from the hexadecimal to decimal and come back to the hexa, and hexadecimal to binary and come back to hexa. So in previous class, I already mentioned about the decimal number. So decimal number, this is the positive side and this is the negative side. How the example 5.1, sorry, 51.15 will be is your number powered. So you can refer the previous video on that. And the common number system on hexa, we're going to focus on this part, and please be careful on the last symbol in new bit, otherwise new bit is not necessary. So all over the symbol is from 0 to F. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, not 10 is A, B, C, D, E, and lastly F. So this is how the hexa number system can be converted to decimal and binary. So we started with decimal 0. The binary is 000, and hexa is also 0. So you're going to have 1, and the hexa is 1. 4 is over here is also 4. 9, the binary is 1001 and hexa is 9. 10 in decimal is considered as A, and then 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So in hexa number is how to convert from hexa to decimal. So this is the power. So each of the bit are represented from base 16 to the power of 0, 16 to the power of 1, 16 power of 2, and so on. And for the fraction, it's going to be 16 to the power of -1, 16 negative power of -2, and 16 to the power of 3. So let's see one example, how to convert from hexa to decimal. So let's say the example is 4a dot 2f. So this is in hexa. So this is a subscript 16, base 16. So 4 and a we're going to put on the left side, and 2f is going to be on the right side. So for a, the representative of a, if you see over here, a is 10. So that's why we have a t is 10, and it times with 16 to the power of 0, and is going to have 10 times 1, and final over here is going to have 10. So 4 is 4 to the is going to represent the same value over here. 4 times 16 to the power of 1, and then there will be 64 plus 10, it will be 74. So the left side is finished. So we go for the fraction. So we can have 2 and f. So for f, we're going to convert it. You can see back the chart. So f is equal to 15. So that's why you're going to have f over here. So you're going to have a 15 over here. This particular situation, because if you see over here, after the decimal point, you're going to have 16 to the power of -1, 16 to the power of -2. So that's why over here you have 16 to the power of -1, and over here you're going to have 16 to the power of -2. And then 15 times 16 to the power of -2 is 15 times 0.0039, and for this side is 2 to the power of 2 times 16 to the power of -1 will be 2 times 0.0625, and the representative of value over here and the representative of it. So we add up this both of the value and we get this value as the answer. So 4A.2F16 is equal to 74.18359 to the decimal of 10. So next is how you're going to convert from decimal to hexa. So this particular method, you're going to use the repeated division by 16 method. So how we're going to do is we're going to divide by 16 and we keep the remainder and repeat until reach 0. For example, 1193 is under decimal and convert back to hexa. So 1193 put over here, divide by 16. So that's why I put over here 1193 divided by 16. So 1193 divided by 16 is 74.562. So this 74 you need to put over here, and the remainder, which is 0.562, you need to times with 16, which give you 9. So this particular remainder you put over here. So this situation, because this is not reaching the 0 yet, so you need to divide again to 16. 74 divided by 16, you're going to have 4 over here. And then since there is a remainder, so you're going to have a remainder of 10 over here. And then 4 divided by 16, so you're going to have 0 over here, and the remainder is 4. And like usual, so the MSB is at the bottom and LSB at the top. So from bottom to top, 4, we put a 4 over here. 10 is equal to A, so you put A over here, and 9 is 9, you just put LSB as 9. So 1193 decimal is equal to 4A9 to the in hexa. So this is a small self-check. So let's say we have 1, 2, 3, 4, and try to use the same method like this to solve this problem. So you can have this as your trial version, and this will be the answer. So you're going to have 1, 2, 3, 4 over here, divide by 16, you're going to have 77.125. 77 will be over here, and the remaining 0.125 times 16, you're going to have 2. That's why your remainder is 2 over here. And then you carry on, 77 divide by 16, having 4 divided by 16, you have 0. So and 4, 13, 2, you put it as 4D2 to the power of 16. You can always check this particular answer with your calculator. For example, if you are using FX570MS, so you just press the mode twice, press 3 to select the base, and then in the decimal type 1, 2, 3, 4 and press the equal sign, and then you select the hexa for the answer. So this is how you do in calculator. So until now, we already able to do the conversion from decimal to hexa by dividing by 16, or hexa back to decimal by to the power of 16. So this is done. Let's check the next following. So this is how you convert from binary to hexa. So if you see over here, I already mentioned we're going to have we already done hexa to decimal. Now we're going to do hexa to binary and binary back to hexa. So this is how we're going to do over here. So by using binary to hexa, the grouping method, how you're going to do this is by grouping into 4 bits for each of the situation in a one group, and before you convert to individual hexa. For example, let's say you have 101100111101. You want to convert to hexa. So first you fill out the binary numbers from right to left. So you started from here 1 0, so you're going to have 1 0 1 1 1 0 0 1 1 0 1. Why you need to do this? Because you need to have one group consists of 4 bits. This is the first group, this is the second group, and you need the third group over here. For let's say in this situation you only have a 3 bits for the third group, so you have 1 0 1, but over here the header you need to put yourself a 0 over here, right? This is the a point extra header to fulfill one group is 4 point. So the second step is to divide these particular binary numbers into 4 bits in one group. So you take out this particular group to here, this particular 4 bits to here, and this particular 4 bits to here, and then later you try to convert from the binary to the decimal number. So you're going for the hexa number. So this is 0101, so it's 0 plus 4 plus 0 plus 1, so that's why you're going to have 5 over here. For 1001, 8 plus 0, so for example 1 here is 1 here, 0 is here, 0 is here, 1 represented here is 8, so the value 8, so 8 plus 0 plus 0 plus 1 is 9, and the last one is 1011, so the representative of 1 over here, the 0 is here, 1 over here is 4, and 1 over here is 8, so 8 plus 4 plus 1 is going to have 13, and the decimal hexa for 13 is D, and finally you get for this binary the answer is 59D to the power subset of 16. So the next one is going to convert back from hexa to binary. So it's some sort like a reverse of this, but more easier. So let's say you have a question FD8 to the power to the hexa to binary. So first you write out this particular hexa number in this particular order. So each of the bit in hexa will represent of 4 bits of binary. So for example over here is 8 in binary is 1000. So you always can check back your chart. So for example this is the hexa 8 and the binary is 1000. So you're going to have the situation for D is 1101 and F is 1111. Then later just combine all of these groups into one single binary system and you're going to have this answer. So FD816, the binary is 1111, 1101 and 1000 to the binary. So I always suggest you need to write everything in a group consists of 4 bits, so it's much easier to read and also it's much easy to represent other than just write very closely enough. So there is a space over here, so this is very helpful. So this is a quick check for the following. So we have done the decimal to hexa and hexa to binary. So from hexa to binary you need to expand hexa into 4 bits per group, and from binary you just group the binary numbers into 4 bits per group and just put it on from LSB to MSB. So this is a self task. From there is 4 questions, so from hexa to decimal, decimal to hexa. So these 2 questions are a little challenging. Have a look on that. So you're going to have a binary to hexa and also hexa to binary. So this is some of the question that you can, so this is the answer, so you can have a comparison between your answer and mine. And the end, we're going to for the next chapter, so 2.4 on octa numbering system later on.